Let's talk about jump discontinuity. What is a jump discontinuity? So a jump discontinuity occurs when the function approaches two different values from the left and the right hand side of a point. And the formal notation of a jump discontinuity looks like this. So your limit as x approaches a from the left hand side is not equal to the limit as x approaches a from the right hand side of the same function. So a jump discontinuity is what happens when this is the case. When the left hand limit and right hand limit are not equal. And visually, I'm just gonna do like a rough sketch. That could look something like this. So you have a function, and then say we have some value 2, and say as you're approaching 2 from the left, your function curves downwards like that. And then as you're approaching 2 from the right, your function just a rough graph, but essentially the limits are not the same from the left and from the right hand side. Let's do a worked example to see how you might see this in your exam and how you're supposed to approach it. So for example, you have some function f of x is equal to x plus 1 when x is less than 2, and x squared when x is greater than or equal to 2. And this is what we call a piecewise function. If this is unfamiliar to you, make sure you review that. I'm gonna jump to the next page. I don't think I have enough space over here, so I'll just copy this. So here, let's figure out what the left and the right hand side limits of this function are, which is the most logical step even if you're trying to just find the overall limit. So we have to figure out the limit as x approaches 2 from the left hand side of f of x, and the limit as x approaches 2 from the right hand side of f of x. So let's start from the left hand side. The first thing you always do when you're trying to solve for limits is to direct substitution, because if it's a polynomial or if it's a continuous function, then you're going to get a real number and you can stop there. If that doesn't work, there's other ways to do it, but that's not the point of this video. So the first step is going to try and do direct substitution. So in this case, the limit as x approaches 2 from the left hand side. From the left is from the values that are less than 4. So it's this is what our function is as we're approaching from the left. If we directly substitute, that gives you the limit as x approaches 2 from the left hand side of 2 plus 1, and that gives you 3. So we got a real number, which means 3 is our limit, our left hand side limit. And then let's find our right hand side limit. This is the equation as we're approaching 2 from the right hand side, because it says from values that are greater than 2 is x squared. So we just replace that with 2, which gives us 4. Like what we said previously, when your left hand side and your right hand side's limit are not the same, then you have a jump discontinuity. So in this case, your limit as x approaches 2 from the left of f of x is not equal to the limit as x approaches 2 from the right hand side of f of x. which means that the limit as x approaches 2 of f of x does not exist. But because this is true, then we know that we have the jump discontinuity. I hope that makes sense.